So look at this example here. If I were to draw a current, it's a sample circuit, and in this circuit we have values of Vs as 5 volts, R1 as 5 ohms, R2 as 10 ohms, and R3 is also equal to 10 ohms. Okay, so let's say we have that. And we want to find out what are the I's. So we want basically I1, we'll label this I2, and then I3. Okay, what are the I's? How do we calculate that? Well, initially, there's several ways. We covered, obviously, node voltage is one. You want to cover mesh currents, another, KVL, KCL. But what about with the, how does this go with equivalent resistance? So this example was a previous example that we did with equivalent resistance, right? Remember how we broke down, this is the same exact problem, so I'll go through here. We broke it down step by step by step, okay? So we went from here to REQ1, from here to REQ1 to REQ2, just like that, right? So how do we go back out? How do we make it where we go back out using voltage and current divider? Because it's the only way you're going to be able to solve this problem. Once you go into equivalent resistance, we calculated I1, okay? So how do we do that? So from equivalent resistance, okay, one of the things we want to do is start labeling the diagrams, right? So here, this is going to be diagram 1, okay? This is going to be diagram 2. This is going to be diagram 3. Okay, so how do we go back out? Okay, so the way to do this problem is very, very simple. Okay, we're going to simply go back to, since we're at diagram 3, we're at I1, which is the same I1 here. The I1 here is really the same I1 that's here. It's the same I1 that's here. Okay, so this I1, they're all the same. How do we go back out? Well, one of the things we want to do is we end up at diagram 3, we figured out I1, we simply go to diagram 2. How do we go to diagram 2? Well, we have to redraw diagram 2. So I'm going to use a blank sheet of paper, okay, to show you how to get this, okay? So we have diagram 3 here. Now we go to diagram 2. We basically write in diagram 4, C diagram 2, just like that. And in diagram 4, we write in the voltage here. Okay. We simply redraw diagram 4, just like diagram 2, and we're going to draw in R1, just like that, and REQ. So R1, REQ1. Okay. Now, how do we resolve this? Well, we still have Vs here, okay, which is 5 volts. We have I1, which is calculated previously from here. Okay, now what we need is, obviously, we need the voltages across this. What is the voltages across these two resistors? The voltages across these two resistors, we could call this V1, and let's just call this VEQ1. Let's just call this VEQ1, just like that. How do you do it? Well, there's 2 ways. The first way is very simple. It's called V equals IR, right? So V1, you have I1 going over R1. So V1 is I1 going over R1, which is what? 0.5 amps. R1 is 5 ohms. So you just go 0.5 times 5 ohms gives you 2.5 volts. V2 is simply I1 right? Over V over REQ1. What is REQ1? REQ1 is also 5 ohms. So you have to keep track, right? So REQ1 is going to be 5.5, which is I1, 5, which is REQ1, which is also going to give us 2.5 volts. Okay? Now, the second way to get the voltage, what we want to use is called voltage divider. Now, a voltage divider is just a shortcut to do this, but in reality, I think this way is much faster, but it's up to you how you want to approach it. Okay? So the voltage divider simply says your V1 is basically your VS here, which is, right, multiplied over R1 over R1 over REQ1. So whatever that total resistance is on the bottom, you add it over the resistance here. So you're going to end up with V1 is equal to, and our VS is what? 5 volts. Okay? So we start with 5 volts. And we have R1 is from previous is 5 here, and then REQ was 5, which is 10. So this is 5 times 1/2, which is 2.5 volts. Okay? V2 is 5 is REQ2, I'm sorry, VEQ2, right? We called it V2, but it's really VEQ2 is what? I'm sorry, VEQ1, I apologize. VEQ1 is REQ1 over R1 plus REQ1, which is again, is equal to what? It's equal to 5 times REQ1, which is 5, R1, which is 5, and REQ1, which is 5, which is again 5 1/2, which is equal to 2.5 volts. Again, if you notice, this answer and this answer are the same, right? And we call this V2, by the way, but reality is this is VEQ2. I apologize for that. This is, I'm sorry, VEQ1, right? We want to keep it consistent with the diagrams, right? But this answer and this answer are the same. Okay, so what do we go from here? Well, we're not done because we still have this diagram left. Okay, so to get this diagram, you simply redraw this diagram as such. Okay, and I'm going to scroll down a little bit to make it easier. So again, we have this diagram, which is diagram 1. So we're going to write in diagram, right? Right, diagram 5 is going to be what? Diagram 1, which is here. Okay. Okay, and I'm sorry about the little sloppy writing. This is kind of a lot of tracking here. So this is VS is here. I'm going to copy diagram 1 over R1, R2, R3. So it's R1, R2, R3, just like that. Okay? And looking at R1, R2, R3, we know from previously this is I1. Okay? The current is very, very critical. But what we also need, as we spoke about the problem earlier, is we need an I1, an I2, and I3. Well, we already have the I1, right? From here, we already got the I1, so because you have to keep track of all the labels, right? So we've got to figure out what I2 and I3 is. And this is really, really easy. It's probably just one step, okay? The voltage divider is optional. You can use this way or you could do it this way. But the current divider is the most critical step, okay? And this is called current divider, okay? And it's not intuitive. You just got to kind of go with the flow, right? I2 is basically I1 times the opposite resistor over the total resistance in the parallel circuit, which is R3, R2 plus R3, just like that. So I2 is going to be we have it here, 0.5, right? Our R3 value, if we look up here, is 10, and our R2 value is 10. So this is 10 plus 10, which is 0.5 over 1/2, so which is 0.25 amps. I3 is going to be what? I1 R2 over R2 plus R3, which is going to be 0.5 over 10, 10 plus 10, which is 0.25 amps, just like that. Okay? So this is how you use current divider in this problem.